2.4 Part D. We're sketching transformations. All right, so again, what's the first step when you're trying to sketch a transformation of a parent function? Say what? The formula. Put it in standard transformation form. Yeah, I would say even before that, it's probably helpful to identify who the mother function is, right? Who's the mother function here? The absolute value of x. Good. So let's come off to the side. We'll say f of x, our parent function, is the absolute value of x. Now, in your mind or somewhere, you were envisioning what that mother function looks like, right? It would look something like this. That's the V for victory graph. It's got the vertex at the origin, sharp turn, and this is going to be some transformation of that. Okay, so now we're ready to put it into standard transformation form. So I've got m of x equals, and the 6 in the front, is that an A, B, C, or D value? That's a D value, so he goes to the back, so it's a positive 6. On the inside, looks like I've got a lot of housekeeping to do, right? I can actually combine like terms on the inside. 2 minus 7 is also known as -5. Now, that's a constant, so I'm going to put that at the back, and that leaves me a negative x halves. I'm going to write that as 1/2 x. You can kick the x factor out of the numerator and throw it off to the side, and now it looks like a number coefficient times x. So you might have multiple steps involved with rewriting, but inch by inch, it'll be a cinch, right? Mile by mile, it's a trial. Don't try to eat the elephant in one big bite, right? You might choke on the elephant. How do you eat an elephant? One tiny little bite at a time. A little salt and pepper helps too. All right. So now on the inside, we must factor out a what from both terms? Not a 1/2, a -1/2. Very good. -1/2. Parentheses, positive x, and now when I factor a negative out of a negative, I get a positive. So what do I get when I factor a 1/2 out of a 5? Do I get 5 halves? No. Remember, you can do this off to the side. We're starting with a -5. We're dividing out a -1/2. Of course, a negative divided by negative is positive. You could do your state change flip, right? Dividing by 1/2 is the same as multiplying by its reciprocal, which is what? 10. Now, quickly mentally redistribute and see if you get -5. -1/2 times positive 10, -5. All is well. Okay, now there's one last thing that we can do if we wanted to. If you ever have a negative multiplier inside the absolute value, you can actually take the absolute value of it. There's this little property that says the absolute value of A times B is the same as the absolute value of A times the absolute value of B, which means you can call that the absolute value of -1/2 times the absolute value of x plus 10. It's entirely up to you if you want to do that. Now, what would the absolute value of -1/2 be? Positive 1/2. So what we could do is we can look at this function any one of two different ways. Okay, if you leave it like this first line, this negative on the inside is going to be a what type of reflection? Y-axis reflection. But if you reflect this graph across, bless you, the y-axis, are you going to see anything? No, it looks the same, right? Because it's what type of function? Even, right? So having it there in the equation doesn't really affect the graph, and that's why we can algebraically also get rid of it. All right? But 1/2, if you leave it on the inside, this 1/2 on the inside would be a horizontal what? Stretch by a factor of 2. That has the effect, when you stretch this graph, it has the effect of making it wider, yes? Wider. And let's see what that would look like. If you make it wider because you're stretching it horizontally, you're pulling it this way, it looks wider. But if you bring it to the outside now, this 1/2 would be a vertical compression by a factor of 2. Will that have the same effect? Yes, right? Instead of stretching it to get it to look like the green one, you can actually compress it vertically and accomplish the same thing. And one of the things we're going to be doing later on is talking about equivalent ways to get the same graph. This is equivalent. So it doesn't matter which way you look at it. Either one of those would be correct. But at any rate, we're going to pick it up now and move it what? The plus 10 moves it left 10 and up 6. Now, every function, as I said, has some characteristic points or features like asymptotes that you want to follow around. The vertex of this one is that point. It still opens up, right? We didn't reflect it down. We reflected across the y-axis, which showed nothing. So I can actually move my vertex, which was at 0, 0, over to negative 10, comma 6. It's kind of like vertex form. So negative 10, comma 6. Let's do that. How about right here? I'm just going to call that negative 10. I'm going to call that 6. And then from there, it opens what? Up or down? Yeah, and we'll just draw it. We'll draw it a little bit wider than normal. There we go. How's that look?
So technically, it is reflected across the x-axis.
Not the x-axis. It gets reflected across the y-axis. But because we're starting with an even function, like we saw with x squared last week, we don't see any change. Now, if that negative had been on the outside of the absolute values, then it would have reflected across the x-axis, and now it opens down. That's pretty significant. But you can't just bring a negative factor that's inside an absolute value to the outside. That's what the absolute value does. It takes care of it, makes it go away. Now, just for kicks and giggles, do you know what this is 2 line segments, right? Do you know what the slope of the line segments are coming in and going out from the vertex? Well, it can't both be 1/2, right? Because one's negative and one's positive. But the positive one is 1/2, and the other one is negative 1/2. Yeah. That number that's out in front of the x, plus or minus, that'll always be the slope of the line on either side. Just like the absolute value of x, the parent function has slopes of 1 and negative 1 coming in. So that's kind of good to know. All right. From there, we can get domain and range. Do we have a local min? Yeah, let's do that. We have a local min of what? Yeah, y equals 6, and it's at x equals negative 10. Now, not only is it just a local min, right? If you zoom in, it's locally the minimum because to the left you have higher values and to the right you have higher values. So it's not just the local min, it's also the what min? Yeah, it's also the absolute or global, if you want to call it that. Usually we use local and global because that kind of has that geography sound to it, local and global. We can also call it a relative min instead of a local min, and then the word relative and absolute tend to go together. So if you call it a relative min, then you're going to call it an absolute min, and if you call it a local min, you're going to call it a global min. But it is the same. It's both the local and the global min. Okay. Questions on that one? What's the range? One last question, maybe. What's the range? Greater than 6? Greater than or equal to 6. So from 6 to infinity with the parentheses. Remember, interval notation is fine. You just have to go from least to greatest. Least to greatest. All right, on your mark, get set. I'm going to let you chew on this one by yourself. Notice the name of the function is what? P, and the independent variable is not x, but t. No big deal, all right? Identify the parent function, put it in a standard transformation form, sketch the graph. I'm going to walk around and see how y'all are doing, and then I'll come up here and try to catch up with y'all. This would be the time in the video if you're watching this at home, or you're trying this one on your own. Or you can fast forward through this part, right? If you don't like P of t, can you change it to f of x? Oh, you're just doing the parent function. Can you?
Yes.
Sure. If you want to redefine the function, that's fine, okay? You're changing the name from P to F. You don't have to file any legal paperwork or anything like that. Just make sure you write it as f of x underneath there, and then I can follow it through. But having said that, I would also encourage you to get used to working with other variables because they kind of have their feelings hurt. They get left out. F and x get all the attention. When you factor out, you're dividing out. Feel free to go off to the side and do that. Stay, change, flip. Good. Now you got to factor out your negative 3/2 on the inside. Yeah, good, yeah. So you did the stay, change, flip right away. Yeah. So what are you left with? Multiply straight across. Negative 4/3, right? So you can get rid of the plus sign and just call it minus 4/3. Now, real quick check. If you multiply back in, what do you get? If 3's divide out, yeah. And your positive times positive is, yeah, and then you get 2. Perfect, perfect, perfect. Here's what you want to do. See, you got it. You put the term first, but now here's your inside, and you need to factor that out. So go ahead. Wow, that happened fast. We were having a good time. You're going to factor that out and then plus 1. So then you can just work on the inside. Okay, yeah, the bell snuck up on us. We will pick up here tomorrow, and don't forget your stories. Also due tomorrow.